Take a look around. Telescopic machines are everywhere, hiding in plain sight. Think of a fire truck's ladder stretching high above the street, or a camera lens that pops out and zooms in with a soft whir. Even your favorite painter's extension pole grows longer to reach the ceiling. These machines all share a bit of magic. They can stretch, shrink, and change their shape to fit the job. What makes these gadgets so special is their ability to pack big reach into a small space. Imagine a crane lifting heavy steel beams, its arm folding up neatly when not in use. Or picture a sliding ladder that fits in your car trunk, yet can reach the roof of your house. That's the telescopic trick big function, small package. It's not just about looking cool or saving space. These machines help people do tough, sometimes dangerous jobs, lifting, reaching, and rescuing, while keeping things safe and efficient. Whether at a construction site or in your own garage, telescopic machines are the strong, silent helpers of everyday life. So, how do they stretch out without falling apart? Let's dive inside and see what makes these machines truly magical. A telescopic mechanism is a set of hollow tubes or sections that slide inside each other, much like the old-fashioned spyglass pirates used. The smallest section fits inside the next larger one and so on, like Russian nesting dolls. When you pull on one end, the sections slide out and lock into place, becoming longer. Why go telescopic? Space saving is a big reason. If a ladder or crane could not collapse, it would be huge and hard to move. Telescopic designs let you store something long inside a much shorter case. It's perfect for tools and machines that must be portable or fit into tight spaces. But it's not just about storage. Telescopic machines can reach places other designs simply can't. Imagine fixing a power line, painting a tall wall, or filming a distant animal. With telescopic reach, the job gets done faster, safer, and easier. In short, telescopic mechanisms turn small machines into big helpers. They make it possible to do more with less, combining clever engineering with practical power. You might wonder, if you slide tubes inside each other, won't they twist, jam, or get stuck? That's where engineering tricks come in. Telescopic machines use guides, bearings, and key and slot systems to keep everything moving smoothly. Guides are like invisible tracks. They make sure each section moves straight, not sideways or crooked. Sometimes small plastic or metal strips line the edges where the tubes touch. These guides reduce friction and wear so the sections don't scrape or grind. Bearings are little rolling balls or wheels placed between sections. They help heavy parts slide easily, almost like a drawer gliding open. Bearings make big telescopic machines strong and easy to move, even when carrying huge weights. Key and slot systems are clever grooves cut into the tubes. A key, which is just a small bump or ridge, slides in a matching slot. This keeps the sections from twisting around each other, ensuring they move in one smooth line. No more jammed ladders or stuck camera lenses. Thanks to these tricks, telescopic machines can extend and retract again and again, always staying straight, safe, and reliable. When you see a telescopic machine extend, it's not magic. It's careful engineering. Most big machines use cables or hydraulics to pull out each section in order, one after the other. This is called sequential extension. Cables work like a puppet's strings. They're wound around pulleys inside the machine. When the first section moves out, a cable pulls the next one along, and so on. This way, each section follows the last, growing the machine step by step. Hydraulics use pressurized fluid inside tubes to push or pull the sections out. When you flip a switch, a pump sends oil into a cylinder. The pressure forces each section to slide out in a set order. Hydraulics are strong and smooth, perfect for heavy lifting. Both systems need perfect timing. If sections move out of order, the machine could jam or bend. Engineers use valves, sensors, and clever designs to keep everything moving just right. So the next time you see a crane or ladder stretch, remember, there's a whole world of cables and fluid power working together behind the scenes. Telescopic machines lift heavy loads, sometimes weighing tons. So how do they stay strong and safe when stretched out? Well, The answer is in their materials and the way the sections overlap. Most telescopic tubes are made of steel or strong aluminum alloys. These metals can handle huge forces without bending or breaking. Engineers pick materials that balance weight and strength. A light machine is easier to move, but it still has to be tough. Overlapping is another clever trick. When sections extend, they don't just touch at the ends. Each new section slides out, but always stays partly inside the last one. This overlap spreads the force over a bigger area, making the whole machine stiffer and stronger. Some machines even use special shapes, like rectangles or hexagons, instead of round tubes. These shapes resist twisting and bending better, adding extra safety. Thanks to smart choices in materials and overlap, telescopic machines can stretch out long and still lift heavy things without a wobble. Let's look inside a hydraulic telescopic cylinder, the muscle behind many big machines. Hydraulics use liquid power to move heavy things. The secret is simple. Liquids don't compress easily, so they can push with great force. Inside a telescopic cylinder, you'll find several tubes nested inside each other. Each tube or stage has its own seal to stop leaks. When the machine operator presses a button, a pump fills the first tube with oil. This oil pushes the first stage out. Next, special valves send oil into the second tube, pushing out the next stage. The process repeats, extending each tube in order. The pressure is huge, enough to lift fire truck ladders, crane arms, or even giant dump truck beds. Hydraulic systems also have safety features. Pressure relief valves stop the system if something jams or gets overloaded, protecting both the machine and its operators. With hydraulics, telescopic machines turn liquid power into jaw-dropping strength, reaching high and far with just the push of a button. Imagine climbing a ladder that suddenly slides back in. Scary, right? That's why telescopic machines need locking mechanisms. These locks hold sections safely in place, whether the machine is fully extended or retracted. There are many types of locks. Some use steel pins that pop into holes when a section is fully out. Others use clamps or wedges that grip the tubes tight. On some camera lenses, tiny catches or springs click to lock the lens at the right length. Hydraulic machines often have built-in locks too. These are valves that trap oil in the right spot, so the cylinder can't move unless you open the valve on purpose. Locks aren't just about safety. They also stop machines from sagging under heavy loads. Engineers test these parts again and again to make sure they work every time. So every time you use a telescopic machine, remember, there's a lock somewhere, keeping you safe and steady. Telescopic machines aren't just for big jobs. They're all around us, in ways you might not expect. Fire trucks use telescopic ladders to rescue people from tall buildings. Construction cranes reach up with telescopic booms to move steel and concrete. At home, telescopic poles help you paint, clean windows, or even change a light bulb. Selfie sticks and camera lenses use tiny telescopic parts to zoom in or reach out. Some desks and workbenches adjust their height with telescopic legs. Robots in factories use telescopic arms to reach and grab items with precision. Even some toys, like telescoping lightsabers, use the same basic idea: sections that slide and nest. Everywhere you look, telescopic engineering makes life easier, safer, and more fun. It's a simple idea with 100 clever uses. The real magic of telescopic machines isn't just in how far they reach. It's in the simple but smart design choices engineers make. Nesting tubes, smooth guides, strong materials, and clever locks all work together to turn an old idea into modern miracles. Next time you see a crane, a ladder, or even a camera lens, think about what's going on inside. Every sliding section, every smooth movement, is the result of careful planning and creative problem solving. Telescopic machines show us that big solutions can come from small spaces. They prove that with a little engineering magic, we can reach new heights, literally and figuratively. So whether you're rescuing someone, snapping a photo, or just changing a bulb, remember, behind every stretch and slide, there's a world of invention at work.